Today we're going to be talking about secants and tangents, and chords technically also, and the angle measures that are formed inside and outside of our circles by all of these fun special segments. So, a secant is a line that intersects a circle at 2 points. And so technically AC and BD are secants because they intersect at 2 points. The measure of angle 1 is equal to half the measure of DC plus AB of arcs. And keep that in mind. Angle 1 kind of intercepts arc DC, and then the vertical angle of that is AB. Versus angle 2 is 1/2 the measure of BC, the arc that it intercepts, plus the measure of arc AD. Okay, so our first example here. I need to find, I assume for all of these, find x. I don't have directions on there, but we're going to assume we are solving for x in all of these. So for A, x equals 1/2 the measure of arc FG, which is 88, plus EH, which is 76. And that works out to be 82. Now here I'm looking for x. Okay, well, I know the relationship between this angle and 62 and 96, and I know that that angle is 180 minus x, and that is equal to 1/2 62 plus 96. So I have 180 minus x is equal to 79. So solving for x, I get 101. Now here for this last one, I know the measure of the angle 60 is 1/2 the measure of one arc plus the measure of the other arc. What I'm going to do is I'm going to multiply by 2 to both sides to get rid of that fraction. So now I have 120. That multiplying by 2 cancels that out. So I have nothing to distribute through. X plus 25, and x in this case is equal to 95. Okay, chord-tangent angle theorem. So when I have a chord intersecting a tangent, okay, and talking about the angles that are in there, the measure of angle 1 is 1/2 the measure of arc AB. The measure of angle 2 is 1/2 the measure of angle of arc ACB. So actually what I'm going to do is I am going to do this another way. So angle 1 is half of that arc, basically where that angle intercepts that arc. Then the measure of angle 2 is half this bigger arc here. So half the measure of arc ACB. Color coding it for you guys. Okay, now some examples having to do with that. Solve for the measure of angle QPS. So the measure of this angle here, where I have a tangent and technically a secant or a chord. So the measure of angle QPS is equal to 1/2 of 250. So that equals 125. So in this next example, I need to find the measure of DCB. Well, that's 360 minus the measure of this arc here. The measure of arc AB, half of that is equal to 108. So that means that arc AB, if I multiply by 2, I get 216. I'm looking for the measure of arc DCB. Well, that's going to be 360 minus the 216 I just found. And that ends up being 144. Okay, exterior angles formed by secants. You're going to find that this is common. It's a common formula. If you look at that, it's always the measure of something minus something. So notice how when we were inside, it was plus. Now that we're outside, we're minus. So measure of angle 1 is half BC, the bigger arc. So half the measure of BC minus the smaller arc, AC. Angle 2, same thing. 1/2 the subtraction of arc PQR minus the smaller arc, which is just PR. You could look at it also like it's the one that's closest to the angle. Angle 3, 1/2 measure of arc XY minus the measure of the smaller arc WZ. Okay, hope I have enough room on this page for all of the algebra I'm going to have to be doing. So I'm trying to find an A, the measure of BC. So set up your equation. Always set up your equation. Okay, so my angle 62 is 1/2 the measure of BC. No, it isn't. You always want to do small minus big. Mr. Pelosi's really good about saying that. Big, I screwed it up. Big minus small. Now plug in. I'm looking for, I know what AD is, that's 141 minus the measure of BC. I now need to solve this equation. I feel like we did one like this before. Multiply by a 2 to cancel out that fraction. And we get 124 is equal to 141 minus the measure of arc BC. Add the arc BC over, subtract the 141. We get the measure of arc BC to equal 17. Now this is a fun one. They tell me this arc here is 103. So going around the other side of the circle, subtract from 360 to get the other one to be 257. So angle B, which is 9x minus 4, is equal to 1/2 the larger arc, which is 257, minus the smaller arc, 103. This right side simplifies to be 77. I add 4 over and I get 81. So x equals 9. Again, another one, I just picked another example that has a 9x minus 7. Kind of looks like the last one, but it's the same process. The angle 9x minus 7 is equal to 1/2. The bigger arc, in this case that's 25x plus 14, minus the smaller arc, which is 84. Inside that simplifies to be a minus 70. Again, I'm going to multiply by 2. I'm going to multiply this whole side by 2 to get 18x minus 14 is equal to 25x minus 70. I get 7x equals 56. So I subtracted the 18 over, added the 70 over, kind of mixed up the locations of the x's and the x's and the numbers, and we get x to be 8. I was worried about running out of space there. Okay, lots of formulas today. Remember, inside you're adding, outside you're subtracting, and then when you're subtracting, it's always big minus little. Think of Mr. Pelosi. He always says this, big minus little. Okay? All right, thank you for watching.